Jai Hind students. In the previous lecture we studied about the frequency modulation part or the frequency modulator circuits. Now we are going to concentrate on the demodulation part, because in the telemetry system transmission and receiving both are important, and at the transmitter section we are actually performing the modulation, whether on the receiving section we are performing the demodulation. For designing multiplex system, it is required we understand both parts, because multiplex system having both technology of multiplexer as well as modulation. FM is the main technique for the analog telemetry principles or the analog telemetry systems. That is why we are concentrating on frequency modulation part. In the previous one we understand about the various frequency modulator that are using direct modulation method using varactor diode or variable voltage variable capacitor or variable reactance devices. Now today we are going to concentrate on FM circuits or the various demodulation circuits. Now as we know that FM modulators are of two types. Similarly, demodulation of FM signal can also be divided into two types that are same as modulation, that are direct demodulation or indirect demodulation. So, any circuit that will convert a frequency variation in the carrier back into a proportional voltage variation can be used to demodulate or detect FM signal. When we are going to broadly classify these type of signal, we have some kind of demodulators, some kind of detectors or some kind of discriminators. So, these all demodulation circuits are known as demodulators, detectors or discriminator. These all are method of direct demodulation of FM. So, starting from the very first, slope detector. Slope detector, actually in this slope detector technique of FM detection, we are taking the slope value, and as we perform in the AM signal demodulation or other signals where we are going to identify the value of the slope of a individual signal, you can use this slope detector circuits. As you are getting a frequency modulated signal which frequency is continuously varying. So, when this particular signal is going to apply at this slope detector, that slope detector is first of all having a tuned circuit. That tuned circuit or tuning transformer is used to detect only the FM signal of desired frequency. Then that particular desired received FM signal is applied to this diode circuit, where this particular lower frequency and higher frequencies are going to produce some kind of voltages. As per this diagram, you can see that lower frequency produces the lower voltages, whether the higher frequencies produces the higher voltages. So, this slope detector is a method of direct FM demodulation, as you are taking the FM signal directly and going to demodulate it. But in this diagram you can see that you are using only one diode, and that one diode is connected in one direction, and that one direction is going to convert only the positive cycle of the FM signal. That is why in advance we are using balanced slope detectors. These balanced slope detectors are basically a symmetrical slope detector circuit in which two diodes are connected in a symmetrical way. Means you are taking two slope detectors, one for the positive cycle, another for the negative cycles, and getting the demodulated FM signal directly. Similarly, we having the another technique of FM demodulation, that is pulse averaging discriminator. This technique is also very important and widely used in telemetry systems, because this is also a direct technique. As I made that diagram, this is the variable frequency circuit, and in this circuit you can see that these are the points where zeros are crossing. Means you can take the minima's point continuously or the maxima's point continuously. What you are going to perform here, actually you are getting this FM input here, and that FM's input is going to be applied at zero crossing detector or clipper limiter. That zero crossing detector is actually a counter or detecting block which is going to detect the numbers of zeros that are crossing between a frequency signal. For that individual counting of zero crossings in a limited slot of the frequency signal, a pulse signal is generated. That pulse signal is applied to this one shot multivibrator. You know that a one shot multivibrator is going to be triggered by these pulses, and that part is going to generate the output signal as per the amount of this pulse. It means the width of the pulse or the timing period of the pulse. If zero crossing detector is generating a 1 second pulse, that 1 second pulse is applied to this one shot multivibrator, and that is creating a signal, and that signal is applied to a low pass filter, and that low pass filter is going to give us the demodulated signal as per the input FM signal. As you know that here the frequency is low, but here the frequency is high, means this time have low numbers of zero crossing, whether this high frequency time have more numbers of zero crossing. Because of that, the one shot multivibrator generation of pulses is also varying, and that varying timing is going to result in the varying voltage through this low pass filter. So, this is pulse averaging discriminator, means these both techniques are direct method of frequency demodulation. Now, the third one, phase lock loop FM detector. Basically, phase lock loop or PLL is a frequency or phase sensitive feedback control circuit which is used in frequency demodulation, frequency synthesizers, and various filtering and signal detection application, and PLL basically have 3 elements. In phase lock loop of FM detector, this is also a indirect method of FM demodulation. For understanding this, you can understand by the construction of this PLL, and PLL have basic 3 elements: phase detector, low pass filter, voltage controlled oscillator. Actually, in phase lock loop FM detector, what is happening? You are getting the FM input here. Here is a phase detector circuit. Initially, that phase detector circuit having no feedback circuits, that is why that direct FM in signal is applied to the low pass filter. That low pass filter is passing the voltage part, and that voltage part is going to apply in the feedback circuit, where a voltage controlled oscillator is generating as per that voltage again the signal, and we are gaining the phase information, means getting the phase detection. That process will be continued till this complete block came into the situation which is known as phase lock loop, in which situation the both phase values of FM input and the VCO output is same in the terms of phase, and we are getting a 0 error signal, and this condition is called phase lock loop condition. And in this situation, the original signal is directly passing through say low pass filter, and we are getting the recovered modulating signal. So, you can see that the primary job of this phase detector is to compare the 2 input signals and generate an output signal that when filtered will control the VCO, voltage controlled oscillator. If there is a phase or frequency difference between the FM input and the VCO signal, then this phase detector output varies in proportional to the differences, as I told you. Then this filtered output adjusts the VCO frequency in an attempt to correct the original frequency or phase difference. Means each time you are getting a new frequency, voltage controlled oscillator frequency is also going to be adjusted as per the incoming signal, and that attempt is making the correct estimation of the original frequency or the phase difference. So, this DC control voltage called the error signal is also feedback in this circuit. When no input signal is applied, the phase detector and low pass filter output are 0, as I told you initially. So, the VCO that operates at what is called the free running frequency and its normal operating frequency as determined by the internal frequency determining components. Means when you are not applying any type of signal, input signal, then that condition is known as free running condition, and the frequency of the VCO in that situation is called free running frequency. So, this is about the phase lock loop FM detector. So, you can easily understand here 2 points. For the whether we are talking about the FM modulation or whether we are talking about the FM demodulation, in both cases we have 2 types of direct modulation method or indirect modulation method. Similarly, in direct modulation method we are using variable reactance devices or Armstrong method in the indirect method. When we are talking about the FM demodulation, we are getting the slope overload detection or zero crossing detector for the direct demodulation of the FM signal. In indirect method, we are using this phase lock loop FM detector, and this is about the basic analog systems that are going to be used in telemetry systems. So, now coming towards the multiplex system. As I told you, we have 2 types of basic telemetry principle operated systems, that may be an analog system and that may be a digital signal. When we are talking about a analog telemetry system, we are going to use a analog multiplex system for that, and analog multiplex system is going to be designed by using frequency modulation and frequency division multiplexing. You can understand here by this FM-FDM multiplex system, you can see that this part is related to the multiplexing, whether this part related to the modulation, and I told you this is multiplexing plus modulation. Now, how it is going to be performed on a telemetry system? See here, we have various sensors in a telemetry system. That systems are basically generating analog inputs that are low level signals of strain gauge or temperature sensors or pressure sensors. They may be single or they be multiple. That multiple input signals are going to apply to the signal conditioner units. For each sensor input, we have a individual signal conditioner unit, which is going to be adjusted by using a calibration signal. That calibration signal is basically calibrating the signal conditioner for the multiplexing part. So, you can see there we have a 16 channel input system in which we have 16 inputs of the sensors. For each sensor we have a signal conditioner. Now, you are going to apply here the multiplexing technique, and you are using frequency division multiplexing. It means in the frequency division multiplexing, the available channel is going to be divided into this 16 sensors equally, means each sensor is going to transfer on a specific frequency region, and that frequency region is going to be achieved by using this subcarrier oscillator. We have 16 subcarrier oscillator starting from 0.4 kilohertz to 40 kilohertz. Each subcarrier frequency is going to change the frequency of incoming sensor signal on a specific region of the frequency division multiplexed channel. That all 16 or m number of inputs and the frequency translated signals are applied to a linear mixer where a combined signal is created, which have a combination of all 16 sensors input. Then this output of linear mixer is applied to the modulation part. In this modulation, first of all you are performing the frequency modulation on this linear mixed signal, or we can say that composite signal. Then that composite signal is modulated, and after that, that is transmitted through this antenna by using frequency modulated transmitter. If you want to understand more this SCO part, you can understand by this. In this SCO, actually you are performing the same frequency modulation on a node point way, that you are taking the input of one sensor that is applying on a modulator where you are using a subcarrier oscillator frequency that is of 0.4 kilohertz, and that carrier frequency is going to modulate first sensor input, and we are getting the multiple frequency modulated or frequency translated signals of multiple sensors. Then we are going towards the receiver part. Here we are getting that FM-FDM signal. Here we are using antenna. You all know that antenna is a electrical device, passive device, which is going to convert the electromagnetic waves into the electrical signal. And this receiver part is just the reverse of transmitter, where you perform the multiplexing and then modulation. In receiver part, first you are performing the demodulation and then demultiplexing. There you use a FM transmitter, here we are using a FM receiver, which is a combination of filtering circuit and the amplifiers. Then that part is applied to a FM demodulator, where FM demodulation is performed using indirect or direct method of the frequency demodulation. Then there is a amplifier circuit. You are using this amplifier to amplify the incoming composite signal, and that composite signal having all the frequency component or all the frequency region signals of the various sensors. As at the transmitter part, you are using this subcarrier oscillator to translate the frequency of individual sensor input. Here we are using multiple band pass filter and FM demodulator for demodulating individual sensor signal from the incoming composite signal. First of all, here we are using the band pass filter, and these band pass filters having the frequency range of 0.4 kilohertz as equivalent to the previous one first one subcarrier oscillator. It is using 0.4 kilohertz frequency subcarrier frequency. Similarly, we have a band pass filter to detect this first sensor input, which is cutoff frequency is FC1 0.4 kilohertz. Similarly, we have 16, that is 40 kilohertz maximum. For individual lines, we have a FM demodulator circuit which demodulate the individual sensors output, and we are getting the demodulated output or the analog output at the end. So, combinedly you can see here one point, that this is a analog multiplex system. So, that is why both techniques of modulation as well as multiplexing, both are analog in nature. You are using FM for the frequency modulation for the modulation part, frequency division multiplexing for the receiving part. So, this is all about the analog multiplex system receiver, and you can understand here one point, that whenever you are want to design a telemetry system which is using analog signals, then it is required you have to choose all the techniques that can process analog signal efficiently. In the next lecture, we are going to concentrate on the TDM, PCM or TDM PAM multiplex system, and you can easily identify here the difference. FM-FDM multiplex system are analog multiplex system, whether PCM, PAM are the digital techniques, and TDM is also a digital multiplexing techniques. That is why these are the digital multiplex system. Both are used for the demodulation, or both are used for the telemetry systems, whether it is about the transmission or the reception. So, in the next chapter, first we understand about the pulse modulation, sampling, and then we talk about the TDM PAM system. Till then,